starting with the scene we left off with in the last lesson, so cloud shape 1 can be loaded in. You can make a few adjustments, and I want to just kind of go over some of the origins of the material. So what I want to do is take the detail amount and set it to 0. We're going to go into the cloud material next, and then go ahead and edit that and change the profile. So under color and density, we can reset a custom cloud layer profile and create a point and make it so that we have a uniform line all the way across. So a full amount profile. Now we have a large cylinder being created because of the stretching going through the full volume. So what I want to do is edit the function. But first I'm going to change the function scale and the overall scale to 1. And we're going to start to see more of that circle. So what we're seeing is the top portion of the circle. And if I reduce the height, we're going to start cutting away at that noise. And then we extend the height, and we're going to see more of the function. So if we wanted to have a circle where we didn't have that sharp cutoff on the bottom, I'm also going to remove feathers and sharpness for now, but I'm going to go edit the material. We can edit the function, and what we need to do is adjust the origin of the noise. So I'm just going to zoom in here, and we're going to select the tooth Gaussian, and we're going to modify the Z origin. So let's go ahead and set that to 2, and that's going to raise it up. And click OK. And now take a look in the view, and we're going to see that full tooth Gaussian with no impact of any of the detail, and we're just seeing that pure noise. So we can adjust the origin to move the volume within the overall height amount. And also keep in mind that the altitude will not modify that Z origin. So if we raise the altitude, we will in fact be cutting into the bottom of that sphere. So the altitude and height basically change the scale of the volume of the noise. And in order to modify the origin, we do need to do that within the individual nodes. If you go to the Lighting and Effects tab, there are a couple of other options. We have the origin of the material, XYZ, and velocity of material origin. Now the velocity is the animation. Any settings you change or make to the cloud animation, direction, rate of change is going to modify the velocity of material origin. We also have an origin of the material itself. This is an overall origin amount that is changed that will control both the detail layer and the density production. However, the Z-scale is basically null. If we take a look, I'm going to expand the preview. Now just how I changed the origin of the material before, I added 2 and it raised it up to make it a sphere. If I was to subtract 2, of course because the scale is slightly different, I would need to about 4. It's not going to modify that noise at all. -500, it's going to be exactly the same. So this Z-scale is in fact null for the density production, and any sort of origin changes made to the Z have to be made individually within the nodes themselves as part of the vector. That will also have a huge impact on the way you animate your functions. So modifying the velocity, if you have the density or noise that's much smaller than the detail layer, they will still move together, and if you did want to have more fine-tuning, you will need to animate those separately. And I'm not going to show the animation at the moment. Take a look at that in a separate section. I just wanted to make a note of that because it is rather important based on this overall origin. So it is, even though the mapping is set to standard, we do basically have a world material that we're moving the altitude and height and kind of moving through the overall function that is generating the individual pieces of the cloud layer. And then the cover amount, of course, increasing the density and more conforming to the output of that noise. So you can see it just moved up a little bit here, and we can start to see that the bottom of the sphere is being cut off. And that's with the full cover, the origin isn't quite high enough. You can reduce the altitude below the slider amount, which is 1 kilometer. So we can bring that down to 0, and that way have a full extending volume from the sea level amount to the top of the cloud layer. Now I do want to talk about sea level too, and we'll be able to see the effects of it much more clearly later. But I want to note, if you go to File and Options and take a look, we do have a sea level option under Units and Coordinates. The sea level option defines the starting point of the atmosphere, and you can raise and lower the value. It will also adjust all of your cloud layers. So if we take the altitude of the sea level and raise it up to 1 kilometer, it is going to offset this cloud layer by 1 kilometer. You can use the sea level to really create some interesting effects going above or below the sea level. Did just want to make a note that it will offset all of your altitude amounts. So at 0, it is 0 relative to the sea level amount, which is currently 1 kilometer above the ground. So I'm going to go ahead and save this scene out as cloud-shaped sphere, so that you can load it in if you want to take a look at some of the settings. I'll come back to it later. I also want to note that we are using this to create the volume itself of the cloud, although we can reverse this if you want to cut a hole in the layer of the cloud. The Tooth Gaussian is really a very helpful fast rendering node, because it is just a noise node, which will render very quickly. So let's go ahead and just decrease the height really quick, and also adjust the altitude amount, keeping in mind that the altitude does offset the height, so the height starts where the altitude will also start. So now we just have this little section right here showing parts of that sphere. If we go into Edit the Material, we can either reverse the density production itself, so going into the function, and one possibility is to add in a filter and set that to opposite. Although this may influence the overall output, you may also need to add in the offset. First, let's take a look at the opposite, where we're going to start to see sort of an inverse effect. It looks like I will need to add in the offset as well. We'll offset that to 1. It looks like we will need to use -1. So now we have the hole cut in the cloud layer. Another solution, rather than going into the function itself, is to take the filter and just reverse it. So if I reset the filter, we'll start at -1, which is -1 on the y, +1 for the x. And we could reverse it that way. We don't have the cutoff that we had before, so I will need to add those additional points in as well. But we're going to start to see the same effect. Because that offset isn't now part of this, we're not going to be able to see the initial or the exact same effect. So sometimes it's better to use just the node itself and offset it. But we can adjust that noise and open up the hole a little bit higher just by modifying the filter. So that's pretty cool. You could also add some additional variations within that part of the filter to change the overall output. So we'll go ahead and take a look at the hole we've cut. And we just have very simple noise. There's still no detail, but a very easy way to define where we want clouds to show up. Now I've got this, obviously a very harsh cutoff just to really demonstrate this. You wouldn't need to have such an immense cutoff. You could have it more gradual by adjusting the filter and also changing the noise itself. But it's a good way to cut out areas that you want to just have clouds in the distance. And if we add a little bit of detail, increase the detail amount, now we have a more interesting cloud layer, still with that overall density controlled by that inverted noise. All of these settings can also be animated, so you could animate the scale of the noise over time. And we'll go ahead and set that up really quick. So we'll take a look. We've got the tooth Gaussian. Scale is currently set to 10. So let's have it increase over time. So we're going to use the time input connected to the scale. Time is going to be returned throughout the function as 1 in 1 second, 2 in 2 seconds. So you could have a direct connection that way, where every second it's going to increase that scale. But what I want to do is have it so it starts at 10 and raise up higher. So what I can do is select the connection between what I just did was take scale and connect it to time. I do have the side outputs, so show parameter connections turned on so that I was able to grab that. If not, what you can do is extract the scale and then reconnect that node. But if you want to limit this, you can add in a filter, choose the map, and then basically what we need to define is saying when we receive this number, we want it to be equal to another amount. If we just want to have it start at 10 and work its way out, so it's 11 at 1 second, 12 at 2 seconds, I could just use a blender and add a constant node, constant number of 10 to offset it, but I want to control the overall amount. You could in fact multiply the number by 5 to also do this. But if we take the lower range, -1, upper value 1, we're going to make the lower value -1 and the upper value 10, which will also work. So we're seeing a very minimal amount now, and that's because the lower value should be set a little bit higher. So we can go back into that function, select the map, set that to 0, open it up a little further. We could set the lower value to 10, upper value to 20 to really define each total amount. 15 to cut it down a little bit more. So let's go ahead and do 5 and 10. So it's about where it was before, and since it's connected to time, we'll be able to see an animation. So I'm going to hit F11 on the keyboard to bring up the animation timeline. And what we need to do is set a keyframe. It really can be anything. If you make a change to any of the sliders within the Atmosphere editor, when you're at a different time than 0, it will automatically add in a keyframe. It'll ask you first if you want to animate the atmosphere. What I'm going to do instead is just take the camera, select it, move in, let's go ahead and 4 seconds, and add in, right-clicking over here, position keyframe. we're just going to add a position keyframe to the camera, just because I'm going to have a fixed camera, but it's going to trigger the fact that there's an animation. If we right-click on this little film reel, we get the animation preview options. I'm going to set this to preview. We can change the frame rate. I'll just do 5. Preview size 4 times. And then it's automatically going to start rendering that out. You can increase the amount of keyframes if needed. But now we can see that animation just with that noise expanding. So it's kind of a cool effect. And what I can do is expand the timeline and then we can see more frames showing. Let's go ahead and take a look at this with that map, setting the lower value to 0 and having it expand 10 every second. So we'll set the lower value to 0. And I'll create a higher frame rate and get more frames, and I'll let that render out. Now if we take a look at the animation, we're going to see that towards the end, as it's expanding, it does close back up again. Now the reason for this is because of the origin and the way the density is set up. So I would need to lower that origin point to more of a mid area in order to prevent the bottom part from closing. Because it is, in fact, it's not really straight up and down. It is still that sphere. If you did want to expand it, you could just change the z-scale of the function output. But we can see that subtraction and then the lower density amount as it closes on the bottom. Just kind of a neat effect that you can do. Pretty straightforward animation. You can also see that it's just animating the noise. And if you take a look at where the detail is showing, it is completely fixed. There is no change whatsoever. So if we wanted to animate that, and now it's asking me if I'd like to animate because I am not at 0. I'm going to click yes, but I'm not going to make any changes. And first I'm going to close out the editor and set the timeline back to 0, and that way I'm not creating any additional keyframes within the center. We'll go back to 0. Now go to the atmosphere editor, and we can change the rate of change, but that is going to animate the entire function along with the detail layer. So if you need to, you might need to reverse whatever's done with the rate of change within the function itself, and there's really a lot of playing around with it that can be done. But one of the main animations can be done is just to change the velocity of material origin on the z, which is going to be the rate of change. The direction or velocity will then change the x and y. So I'm just going to type in a value of -0.1 on the z. And this might bring down our noise as well, and what is causing that circle to show up. And it does look like it wasn't quite enough to show that, and that's because the rate of change is set negative here. I'm going to go ahead and just type in a value of 0.5 within the rate of change, and then if we take a look, we're going to see it's going to set that to 0.5 and the velocity of material origin. So we'll raise it up. Hopefully we don't lose all of that noise. So there is a little bit more of a change within the detail layer. It is very small because of the scale of the material in relation to the detail. But there is a little bit of turbulence showing up there now. And we can see still a pretty neat looking effect. So that's just a very basic animation. If we want to have more of an impact of the detail, what I can do is increase the roughness and scaling. And what I also want to do, we'll just add a couple more keyframes to make it more interesting. I'm going to take the height, reduce it to about 1 kilometer, and then at the end of the animation, we'll go ahead and bring that over, go back into the atmosphere editor, set that up to 6 kilometers. Now if I go back to frame 0, we're going to see a height of 1.1, and at the end we have those new keyframes. So we can open up some of the other panels if we want to take a look and see the atmosphere and its keyframes. So right now we have the atmosphere with stretch stratus being the layer we're modifying, and then the keyframes showing up in there. And as it's raising over time, let's go ahead and close those for the moment. And I'm going to create another preview. Now if I scrub through, we can see the animation. Now there's also a lot of grain that's showing in the preview, and it'll probably show in the main render as well. And that's probably because I have the roughness settings set way too high. But you can see more of that detail layer showing, and that does make the animation a little more interesting. So just a very simple way to punch a hole through a cloud.